Hello. Okay, we're going. Let me organize everything here. Oh boy, this is gonna be the most exciting stream here. We are doing C Sharp 101, which is mostly gonna be a lecture. It is going to be so exciting. But no, it'll at least be a little bit interesting, I think. I tried to retrofit my presentation that I usually give for teaching robotics, because we use Java in that, but I always teach C Sharp since it's similar enough, and it's easier to learn C Sharp in a vacuum rather than learning Java in a vacuum, because at least with the robotics programming, you need to have like the robot ready to go, and it is not always the case that you have a robot ready to go to program. So learning all those concepts is definitely useful to do that in C Sharp first. But we will see. But yeah, so I've retrofitted a bit of that presentation to be more applicable towards Godot, and added a little bit of Godot stuff at the end. And I think we should be ready to go. Okay, let me undeafen. Okay, Let's see. Discord's using the correct mic. Make sure, maybe. Let's see. Okay. Yeah, it was just, I was like eating the mic too much. It was picking me up breathing. Okay. Let's see. Is Nellian ready to go? Oh, I've got mail. Blockbuster 1130, thank you for the follow. Okay. I think he's ready. Okay, I'm gonna drag him in here. Ready or not.
Excuse me while I drink some water. I still have like a cough, so I might mute myself often while we do this. So I can cough off stream.
Are you ready?
Ugh.
Are you
Do
excited?
I sound like I'm ready? Yeah, I'm ready to be back in college, seeing the back of the lecture,
Oh
falling
yeah.
asleep.
Oh yeah.
Mm-hmm.
Okay, let me get my screen share going for this. And then let me also go boop and boop. And I think we should have everything ready to go. So,
All right, give me one moment to set up my sources.
yeah.
While I do that, how are you doing today, Mr. Skeleton?
I am doing.
Well, I guess that's better than not doing.
Yeah. I'm glad it's not 300 degrees, although now it's just really fucking humid out. I'm only mildly
It's
dying
not
now.
that bad.
I was up
The
at
window
like
capture.
fucking 6 in the morning because it started raining, and I'm like, oh god, I left all the windows open, and I didn't want like any wind blowing in and getting all my shit wet inside the windows, because like my TV is right
What?
next to the
You
window.
didn't? Oh, okay. Yeah, that would probably be bad.
Yeah. Well, on one end it's my TV, and then on the other end of the room with the other window that I leave open, it's my record player. So
Yeah, two things you probably don't want to get wet.
yeah.
They not
Thankfully,
like us.
nothing
They not like us.
did get wet, which is good.
Okay,
But
traumatizing AI like you was 10 seconds ago. Have fun traumatizing AI Blockbuster. You're kind of quiet today. Oh, let me turn myself up. Let me know how that is. This sort of thing. Okay, so I now have the presentation up, and I have one question.
Yes.
This says that we're learning C sharp, but I thought we were learning Python.
Oh God.
So you're not teaching me Python
No, no,
is what I'm
we're
hearing.
not learning Python, no. I don't even
Yeah.
think I know enough Python to be able to teach it. Python
It's a
fucking
womp womp.
sucks.
Damn.
Yeah, that's
That's a take.
my hot take. Python fucking sucks. It's bad. Don't use it unless you absolutely
Damn.
need to. But then again, anything you can do in Python, you can do in C. So just
You
use
both us now.
C.
Okay. Cool. Thanks for the auto check, Kitty. Okay, Skeleton Man, you are now large on my screen. I'm ready for your lecture.
Oh boy. Okay. So I'll preface this with what I was saying right before I yoinked you in here. So this presentation originally is the presentation I used to teach C sharp to high schoolers that are in the robotics club, because I mentored for many years on my high school's robotics team as the like programming mentor. So I had to retrofit a lot of this. um,
So
so
is
there,
this or is this not still at the level 4 high school?
this is still pretty much high school level.
So it'll be
Us high
very bad
schoolers.
if I don't get this.
Well, a high schooler that is interested enough to join robotics, I'll say. So I don't expect you to instantly understand everything, and that's why I encourage you to interrupt me whenever to ask questions. Because there's definitely a lot that's not going to make sense, and I don't know what doesn't make sense to you unless you ask a question. So,
All of it, but go on.
yes, exactly. Okay, let me reorganize my windows because I have a billion fucking things everywhere. Okay. So, yes, object-oriented programming. And this is in C sharp. And a lot of it at the start is it's very C sharp in a vacuum. So not necessarily Godot related, but it's, it's the language basics. And then at the end, there's a little bit of Godot specific stuff. And then after that, I'll be doing kind of like a live tour walkthrough of like a little bit of like the actual Godot engine, like the editor itself and how it looks and how you interact with it. So
Sounds good.
okay.
I'm already not lost, so good sign. Good sign.
All right. So a little history trivia. What is C sharp? So originally it was created to be Microsoft's answer to Java, because Java was the thing that everyone was using back in the like 2010s. Everyone is using Java. Java has some weird licensing issues. It's kind of bad. So Microsoft, of all people, said, well, let's just make Java, but like good. So they made C sharp. Lots of it, lots of parts of it are free and open source. They kind of maintain and manage the language, but it's not like Java where it's like they have a copyright to Java. Like they don't maintain like a a copyright or licensing or whatever for C sharp. It's all open source. Very cool.
Oh yeah, open source is very cool.
They don't charge for commercial use cases, which is a thing that Java did that's really shit. And also it doesn't use as much overhead, like not as much, CPU, RAM, and everything as Java does. And so C sharp.
Then is there any like way that Java is better than C sharp now, or is it just C sharp or bust?
Realistically, there's not much of a reason to use Java anymore except for legacy applications.
Okay.
Like obviously, like I was saying with the robotics. So this is why I teach C sharp instead of teaching Java for high schoolers, is because it's almost the same exact syntax. Like it looks the same. It's almost all the same like functions and everything. So if you learn C sharp, you are also at the same time learning Java, which is why I would teach C sharp, because it's easier to like learn C sharp in a vacuum and like make a program just that runs in the terminal rather than dealing with Java and trying to create GUIs and that, and everything sucks. um,
Gotcha.
but yeah, so then what else? .NET similar to Java, because so Java is cool, or was cool, because you program one program in Java and it will run on anything and everything. Because it technically is running it in a VM. .NET does the same, but it's better. So you'll hear me say .NET. Just replace .NET in your mind with C sharp, because they basically mean the same thing for all intents and purposes. And so C sharp is used a lot in the game dev sphere, way more than Java anymore. Pretty much just Minecraft uses Java for like as its engine or language, really.
Yeah, but
Anymore.
Minecraft is really popular, therefore Java good.
Yeah, I mean, you joke, but there is people with that mentality, unfortunately.
Oh.
Yeah. Do, 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 do. And then this is kind of a thing we'll get into maybe later, but it has a similar to Java. C sharp has a garbage collector, which is very nice, which means you don't have to like, allocate, X amount of bytes of memory to store this data in here. It just does it. You don't have to worry about it. You don't have memory leaks. You don't have to deal with any of that bullshit. It handles it.
That's Pog.
And it's also just better in general. Okay.
That last point seems to be the most important.
Yeah, it's just better. Okay, so what the hell is object-oriented programming? What does that look like? So, did that skip a slide? Or no? Okay. It's a little unorganized. Okay, so our basic kind of programming logical concepts to keep in mind. And you'll see these when we look at like actual code later. First off, you have your if-else statements, which pretty much is just if something is true, do this thing, else do a different thing. You see that constantly. Everything that's like true or false, or, if something is equal to something, you use that. For loops are useful. This is basically, say I want to like run the same code like 10 times. You put it in a for loop that will loop it over and run that same code 10 times. So you're not like copy and pasting all of your code 10 times to do a thing 10 times, which is,
Just tell the loop to do it 10 times.
yeah, very
Gotcha.
useful. And similar to this, there's also while loops, which are basically loop infinitely until a condition is false. So we could say like, while something is loading, keep checking, and then as soon as it loads, then we're done checking, or something like that.
Wait, are you saying like wow, W-A-W, or while?
While.
Oh, okay. It
Yeah.
sounds like you're saying wow, and I was like, oh, I've never heard of a while loop before.
Oh, that's my good pronunciation there.
Yeah.
Let's see. Oh yeah, so then case statements. So the way I always think about case statements is that it's like a radio button, which, let's see. I'll hide myself for a second on my stream. So you have these different buttons here in a radio button setup, and you can only select like one of those. And so what a case statement is basically like, hey, I want to run this case statement and check this variable. And then we say, okay, here's what to do if the variable says, attack, or if the variable says defend, or the variable says whatever. And then you can list out all these different cases for what to do if something is equal to something. So, and these are way more efficient as like a thing to do if you need to be running this, a million times a second, instead of saying if it's this or that or that or that or that or that. Using case statements is way better. There's a lot of memes about what's his face, the Yandere simulator dev.
Oh yeah,
Everyone makes fun of him. Um,
I've
there's
heard he has like the most spaghetti of code.
oh my god, he has like some of his code is out there where it's like it's just a million if else statements for everything in the game, and it's like, bro, you could have like a case statement and then it's not like super laggy. But yeah, case statements are very cool. I really like being able to put things in case statements. Um, so that's some of the basic logic stuff. Um, oh, okay. Now we're back to this. I don't. As a side note, I fucking hate LibreOffice. Oh my god.
What is LibreOffice?
This is the Linux version of Microsoft Office. It fucking
Oh,
sucks. Don't use it.
okay, okay.
Yeah, it totally fucked up my presentation. So like half the fonts are wrong.
Yeah, blame the program.
Yep, yep. Okay, so object-oriented programming, as defined by Wikipedia, it is object-oriented programming is a programming paradigm based on the concept of objects, which can contain data in the form of fields, often known as attributes, and code in the form of procedures, often known as methods. So that's very fucking dense, but the key term takeaways from this are you deal with objects, you have attributes, you have methods, there's classes, and there's data types. And we're going to cover all of these individually.
Okay, thank God I don't have to remember what a paradigm is.
Yeah. So the way that I always kind of start off with explaining this is that objects, because you hear object-oriented programming in classes, and it's like, what the fuck is that? So the way I always explain it is I think of it as like a cookie cutter. So your cookie dough is all of your data. So like, say my end result is I want to make like an object that defines like a player's, like a player in a game, like their character. So your data, your cookie dough, is probably going to be like, what's their username and what's their current HP and what's their inventory contents and what's, their abilities they have and this and that and this and that. That is all of your cookie dough. The cookie cutter, this is your class file. This is where you define, okay, we have a slot for a name. We have a slot for HP, for inventory. We define things like, the player might have a jump function, or they might have a dying function, or they might have a respawn function. All of those things are going to be defined in here. And then we combine these two to get our cookie in the end, which is the object. This is the actual, like, in the game, the character or the item or whatever, right? That is our end object that we have. And then we can do things like we can say like those functions that we defined up here, we can actually run those, or we can read out that data of like what is the player's name or what are their inventory contents. That is all stored in here. And like a cookie cutter, this is defining like a template basically. So we can make multiple different instances of this cookie or this object. We can make multiple different copies of it because this is just defining the template, and we just need more different data to shove in there to get out another copy of it.
Okay, so you could use like that same template or that same cutter with different dough to make the cookie.
Exactly. You can have like and so this analogy goes for mostly just the basics of like one class not inheriting anything. We'll get into class inheritance in a moment, and that's when things get kind of wacky and wild, but it's also really cool. So this wall of text, wall of text, you do not need to worry about memorizing. This is just this is just kind of to point out a couple things here. So these are all the data types in C#. And now a data type is, you might think of like like how do you store a number? Well, there's a lot of different ways you can store a number. Like these are all, well, I guess not bytes. Well, no, I guess
Add
you
your
can. I guess bytes you can store. Yeah. Okay. This is all numbers, and these are all useful in different ways. So, like a byte, for example, only stores the values from 0 to 255. Um, Depending on your use case, you'll use any one of these. Mostly, all I ever use when I'm programming is if I need an integer, which is just, any whole number. I'll use int, which is integer. And it's a signed integer by default, which I'll get into that later. But really, a signed int for the most part is what you'd want. Floats and doubles you use pretty often, which are basically just basically like, decimal point numbers with decimal points, because an integer is a whole number. Floats and doubles store different varying levels of precision, so how many decimal points it can go to. So a single is, or a float, which is a single precision floating point. So it has, I guess, 32 bits of decimal place, which is pretty precise. And a double is even more precise. Realistically, 99% of the time, these things are interchangeably used, and the only reason you need to use one or the other is because whoever programmed their thing originally used one or the other, and they're not directly one-to-one, because obviously you're losing data if you convert between them. So for the most part, these are interchangeable. I never use decimals.
Wow.
Char I almost never use unless I need to. Char is just a single character, so like the letter A or the letter B, that's a char. Bool is boolean, which is true or false. Very, very frequently you use this. This is for any time you want to like make sure that something is true or false, or enable or disable something. Bool, use that constantly. Object. This is kind of what everything that's an object inherits. So obviously we're going to be using that one a lot. String is any sort of like, so I just realized my cup is covering all of this. Okay, hide that. String is basically like a string of text, a sequence of characters. So like if I have like a sentence written out, that would be a string, or a username is probably a string. And then date time is just, date and time expressed in like a specific variable. But yeah, for the most part, floats, doubles, bools, object, string, and int are the main things to keep track of. And you'll get used to like knowing what things to use where, because it'll just make sense. It's pretty straightforward. Okay, and then so I mentioned signed versus unsigned. This is not too important, so don't worry about trying to remember this, but just know that
Say no more.
Yeah, there is, just note that there is a difference between signed versus unsigned. So signed means that it as the name would imply, it has a sign, so a positive or a negative, right? So a signed integer, which, going back one, we have our int and our uint. So uint is unsigned and int is signed. Come on, next slide. Okay. So signed just means that it can do this is inverted. This is just wrong. Okay.
It's
this
okay,
one,
blame
this
the
one
program.
This one here, this is unsigned, and this one is signed.
I
Okay.
love the improvisation right there.
Yeah. So signed means yes, that it has a positive and a negative. And unsigned means that there is no negatives, but it can store a larger number. So C sharp is signed by default. Um, the Realistically, most of the time you're not going to be dealing with numbers that massive to need to worry about that. But if, say, you are making a game where like players can have incredibly high, giant, billion, trillion levels or whatever, that would be important. Um, a
You could make games
famous, a,
exclusively like that.
a famous story that you'll probably be familiar with related to that is in which was later disproved as like just an urban legend. It didn't actually work like this, but it was like a programmer urban legend that in early Civ games, Gandhi, they used the wrong data type for his happiness. And what ended up happening is they thought they were using signed or unsigned, but they needed to be using the other. And so what ended up happening is once it reached the upper level, it ended up looping back around for his like friendliness and happiness level. Is if he was too friendly to somebody because he starts out pretty friendly,
Hmm.
it would end up overflowing, or well, underflowing is what they call it. And it loops back around to it reads that data value as, ultra negative. So then he goes insane and starts nuking everyone.
Let's see. I do remember hearing he was the most likely to use nukes. If that was the urban legend, do you know what the real cause of that was then?
The real cause is that it didn't actually happen, and that it was like put in as an Easter egg later, I think.
Oh,
Yeah, but that is a realistic scenario of like things like that can happen where you overflow numbers and it freaks out. Okay, so here's some examples from my college homework, which is what a lot of this early stuff uses as examples. So this is the example of what like a class looks like. So this is our cookie cutter here. We're making a inventory item class. And so this was for an assignment for making like a what would you call it? Like a program to manage the inventory of like a store or something was like the assignment. So
okay.
this class, and don't worry about the getting and setting, this isn't important. These define like uh okay, this is a class that says like we have, we define some variables in here. In terminology, you might hear these variables defined as or called members or parameters of a class, but just know that that means basically like these are the components of it. So we have an item number, which is an integer. We have a price, which is a decimal, which is fine for this case because prices don't go past, like uh whatever, like a penny, right? You don't count lower than a penny. So decimal is fine in this case. And then a string of a description. And so when we're creating an inventory item later, we can set all of these things. So an item will have, its ID number of what item it is, its price, and then its description. And then this right here, this function that is just public item or yeah, inventory item. This is what's called a constructor. And so a constructor is what function is run initially to create the object when you create one later. So in here we say, okay, when we want to create an inventory item object, you can say you can set the item number, you can set the price, and then you can set the string. And then what this does is when you call this constructor, it then forwards these variables that you passed in, and then it sets them up here, these other variables that are internal to it. This is a little convoluted of a way to do it, but well, I mean, I guess this is pretty standard. It just looks a little confusing. The other thing is I have default parameters for all of these, which is not something that you normally necessarily need to do. So if I just create a new inventory item, but I don't set anything on it, I don't give it a item price or description, by default, so it doesn't error out, it's going to create one with where its item number is 0, its price is 0, and just nothing, blank, as its description. So then we also have two other functions here. We have get display text and return item. So this is dumb. This is bad. Don't do this. I was dumb.
Too late. I've already done it.
Uh-oh. I was dumb when I wrote this. This is silly. You don't need to do this. But this makes sense. So I wanted a function that makes a single string. And so this is where we start having return types. This function will give you back a string. So a string of text. And what I wanted to do here is I wanted to get like a single string that has a nice formatted display of this information for just displaying on like a user interface. So what I do here is I'm returning a string where we take the item number, turn it into a string, plus a space, plus the description, plus a little bit of a space, and then parentheses, $, the price, parentheses, and then so that would end up looking like, item number 5, space, description, parentheses, $5, like that. And then I could then say, okay, grab all the items in the inventory and just give me a nice display for them to just generate a list that the user can look at.
Why do you need to turn the item number into a string but not the price?
Because I'm dumb, and it will do this automatically. It will automatically do the toString, but when I was writing this, I didn't even think that, oh yeah, numbers are automatically converted to strings in C# when you use them like a string.
Cool.
But theoretically, this same function you could put here on the price to convert it to a string. It makes no difference really, because when it compiles it, it will essentially do that anyway for you. So you don't even really have to worry about it. What else? Okay, and then so this thing is stupid. Like, this function does not even need to exist. So just ignore that this even exists. It's bad and stupid. Because if you wanted to get the item, you would just say, you just grab the item itself, like the object. I don't need to have the object run a function that returns itself, because you just already have it. So this is stupid.
Gotcha, I think.
Okay, so now that we have this is how we would actually make it. This is kind of weird because this should say like inv item right here. So we'd say like inv item temp item is equal to a new, and this new keyword means we're making a new copy. So this is the cookie cutter, and we're saying using the cookie cutter class of inv item, we're going to say convert to an int. And so in the UI that I made for this, it was all text boxes that you enter stuff into. So, which is kind of a stupid thing to do. but that's what we had to do for this class. And so this convert dot to int32 takes the text in a text box and it turns it into a number. Same thing for the price, and then the description we just take in there. And then that then in this variable that we called temp item, it takes all this and it turns it into a real, the actual like cookie, the actual class, or the actual object made from the class, and it puts it in there. So now we've assigned it. So then later we can do, I guess this is just more of an example of kind of the same type of thing. So let's see, what are we doing in this? Okay, so this is what we're doing is so this is another a for loop, but this is called a for each loop. These are really cool. These basically, if you have a list or an array or whatever, a table of something, you can go through that and grab out and do something for each one of the items that's inside that list. So inv items is a list from the database. So we're calling this database and we're saying, hey, get us back the list of items. It puts it in there. And then we're going through and checking each one of these, and we're creating a temp variable name that's just called item. And then we are, I guess we're going through and we're creating a new copy of those items based off of the information that we're getting out of these copies. This is also really dumb. There's no reason to do all this, but it was part of the assignment. But it shows you kind of like how you'd kind of interact with these things. Okay, so methods and functions. This is something that you'll hear interchangeably. I end up using these terms interchangeably, but they literally mean the same thing. All a method or function is it's a part of code that when you run it, it does everything that's inside. So the like if we go back one, the fill item list box, this is a function. And so later in my code somewhere else, I can basically just type this out and it will go then and then do all the stuff in here. And so that way you can kind of, you're essentially reusing code because you're just saying, okay, yeah, do this function. And so from multiple different places in my code, I can say, hey, refill the item list box, like refresh it, and it will go through and do all this stuff that I have in there. Okay. And another key point is that they can return values. So if you see void, you'll probably see this a lot. This means don't return anything. We don't need any information back. Just go do this function. Just go do everything in there. I don't care what the result is. Just go do it. But any data type. So like this one returns a bool. So this one is basically it goes and it checks all of these different variables. If there was some class that I had written for this class that, or a class, the programming that I wrote for a physical class I attended for this assignment.
Yeah, I gotcha.
Where we had to write like a validator program. And so this validator program just checks all of these different variables and makes sure everything's correct. And then, so I wrapped all of these function calls up in one thing that just says is valid data. So then later I can say if is valid data, and then it checks all of these, and then it says, if it is, do this, else do this. And you can even return custom item or custom data types or like objects. So like I can say get an inventory item, which again, this is stupid, but this is useful because then you can define like custom ways to get out of other data. You can automatically construct objects that you need. But yeah, so basically you can, any function defined in your code, you can say it returns a variable, and you don't necessarily need to do anything with those. So like if I wanted to just say, if I just wanted to run isValidData and I didn't care what it returned, I could just run it. It wouldn't really do anything. Like it would check this stuff, but it kind of just throws it into the void, the result of it after. So it doesn't really matter. But if I
and does that just return true or false?
Yes.
Bool?
Yes.
Okay.
But yeah, so you don't necessarily need to use the results of things, but you can if you would like. So past that, we also have, so there's objects, interfaces, and structs. These are kind of the three main ways to organize data. So obviously we kind of have covered objects, which is, classes. But there is also interfaces and structs. So an interface, which we'll look at in the next slide, this defines a function component that can be added onto an object. So an object that doesn't necessarily have a definition for like a certain type of function to it, we can just add it in, even if it's not in its like class ancestry. And then structs are, they define a value type, which is very similar to objects, but it's pretty much only used for storing data. So you don't really have too many functions inside of a struct. So like an example of a struct that I would use is like, if I wanted to say have a, well, like for example, the inventory item from the previous example, that very well could have just been a struct. There really didn't need to be any functions on it. I could have just made that a struct and just say it, this inventory item contains these three variables, and that's it. And that's all a struct is. It's basically like a variable that contains other variables. They're very simple to deal with. So objects and interfaces, the way I always explain this is that it's kind of like, think of it as like categorizing like a phylogenetic tree of animals and stuff. So an animal, you might so I guess to preface this, classes can inherit other classes. And we'll get into that when I'm like kind of showing examples of code. But
some of this I'm foregoing my confusion for when I actually do it.
What was that?
Nothing. Never mind.
Oh,
continue.
Okay. So yeah, it's like classes can inherit other classes. They can inherit functions and variables from things that they have an ancestry to. And people can get really wacky and wild with like multiple, like many layers of inheritance, and it gets really messy. But in like this kind of example here, if we're going to compare it to like animals, right? You have your base class animal, and this defines things like, an animal needs to know how to eat food. Like all animals need to know how to eat food. And they all breathe, and they all reproduce. And so that's kind of your basics of like every animal has these things. So then we can say, okay, well, if I want to make a mammal probably would have things like they need to be able to dig around and burrow underground. A lot of mammals can do that. They probably need to be able to swim. Mammals generally know how to swim. And then things like, like they can grow fur. All mammals grow fur. Okay. And then we can have another thing that's an animal, that's an avian. And avians can fly. They can make nests. And now these both, if these were both classes, or well, say an object that just is a straight up avian, I could say, in my code, I would be able to say, if whatever object that I've created that inherits avian, if avian is animal, then do this, and that would return true, because an avian is an animal and inherits it. But an avian is not a mammal. So you have these different layers of all of this stuff up here is essentially like, replicated down in your thing that is the ancestor. Or I guess not the ancestor, right? Is that descendant? That's the word I'm looking for. The descendant receives everything from its ancestor of all of the functions in there. And it can define its own way that it does that. So the way an avian eats food is probably very different from the way that a mammal eats food. They each get the eat food function. And so in my code, I can say, okay, find all of the animals in the game or whatever, and run their eat food function, because I know that every animal has to have eat food. But avian might define its eat food function as, I don't know, go crack open a like a tree nut and eat that, versus a mammal might, in its eat food function, it might be like, a predator, and it might be like hunting, so it has to like go, hunt down another animal. And so they can each define their own body of each function.
So, like, if I were to be making like a new avian, when I make that, do I have to define the parts of it that make it an animal, or can I like define that later on, or like when I make that avian, I have to define the pieces of the avian and the inherited bits of the animal as well, or will it just like, or like if I didn't, and then I did what you were talking about, try to figure out the difference between this avian and some other mammal that I made, would it just like say, oh, the avian doesn't have anything like defined for this for eating?
So both of these, the different examples here, the platypus and the crow, these are both the actual objects. These up here, these are all classes. I probably should have labeled that. These are all classes.
Oh, okay.
And so
Whoopsie.
in this class, you define all of that stuff, and then when you actually make the final object, you're basically just filling in the blanks of like, all the details about it, of like, these are its, stats, its name, its whatever. All of that is what goes into making the final object. But I guess this is also slightly misleading, because actually no, these are classes technically. But you would say you'd make an object of this final class, because crow might be like, okay, you define all these functions in crow, and then you also say like, okay, but crows also have like some functionality for like herd behavior, where they team up. And then the yellow here, this is what's known as an interface. An interface means I can define specific functions, or even just a singular function, and attach that like definition for that function into any class anywhere. So, for example, all avians need to lay eggs. So I'm going to define lay egg out here in its own thing. But avians are not the only thing that can lay eggs. A mammal can lay an egg, a platypus, but not all mammals lay eggs, so it wouldn't make sense for it to inherit it there. Versus something like, like if you had another class over here that's like reptile. Reptile, I think there are some reptiles that give live birth, but we'll say for the sake of the example, all reptiles lay eggs. So reptile would inherit egg laying, but then I don't need to re-inherit it down when I'm making, like a lizard or, a turtle. Um, but then I can say like, okay, everything that can lay an egg, I just run this function on it, and I can find everything that has that inherits egg laying, and I can check and see if something inherits egg laying by saying like, I believe off the top of my head that you can just literally just say like, if platypus is egg laying, and you specify that interface name, and then it would be able to tell you if it is or isn't, if it has that function. Um, and so at any point in here, you can attach interfaces into things, and then things down the line will inherit them. And the extra nice thing that you can do is if I had, say, another interface out here for saying like flying, right? Because some mammals can fly, I could then remove that there. I don't need avian to know how to fly because it just inherits the flying interface. And then I can say like, well, some reptiles can like fly sort of, and some mammals can fly sort of, like bats. I mean, bats totally can fly. And so you can break things out depending, and this is where it kind of becomes a matter of how your own brain worms work, is how does it make sense best to you to organize everything. Of, should something like fly be something you define for specific things, or should it be an interface? It all depends based on, when you're actually writing code, it may be like, and I'll show some examples of interfaces in my game. But, depending, it might make sense to either have something inherit a specific class, or it might make sense for it to inherit from an interface. And that's where it becomes very cool, is I can do multiple inheritance. I can say avian inherits egg laying, flying, this, that. And then a la carte essentially choose what functionality I want in a class. And then it can define what it does for the specifics in its own class. Any questions on that?
I'm sure I'll have many when I try to do it.
Okay.
It was a lot, and I think I have the gist.
Yeah, it definitely is a little convoluted. Once you actually see it in action, I think it'll make a little more sense. But
yeah,
the key thing to keep in mind is that everything inherits from something else. There's always like my player character might inherit from character body 3D, which inherits from a kinematic body, which inherits from a node 3D, and which inherits from a node, which is like, a base type. So it's like a whole thing. So as for Godot specific considerations, this is a little bit in the weeds about it, so don't worry about trying to understand this too much.
Oh boy, I'm gonna put on the boots and hike up my pants or get in the weeds.
So I was looking through this, and there's only like two big considerations I could think of. And I even read through their documentation for this to make sure there was nothing I was forgetting. And these are the two major ones. So Godot uses signals for its observer pattern. And now an observer pattern, to step outside of this for a second, an observer pattern is essentially like, I want a way for code in one place to watch code in another place. And now that could either be the code watches the other, and when I say code, I mean like objects watching each other, like running code.
Okay.
An object to watch another object. When I say like, okay, when this object dies, I want you to play a sound. Okay. So in base C#, you would use a thing called an event, which events are emitted from an object whenever you emit them in your code. So if I was making an object like a character, and in their dying function, I would say call an event or throw an event called character died, and then other code elsewhere can effectively subscribe to that. It can subscribe to that event where I can say, hey, when this event is emitted, call my function for emitting a sound. And so any number of objects can watch any other number of objects' events. And that's very useful. And you can still do that in C# in Godot. However, Godot has its own form of events, which it calls signals, which are given kind of like first-class treatment in that these are the more supported way that you're supposed to do things. So in my example down here, I have a timer node in my scene. And so what I do is I run in my ready function, which is essentially when something is like loaded into a scene, it runs its ready function when it's done loading. And so this is basically the first code that's run. So like this is for an explosive barrel, right? This is its ready function. And so we say we turn off its smoke particles. We set those off, and then we set its max HP to be equal to its HP variable. But then we say, okay, our timer node here, that's the this is what this does in game is a barrel will be on fire for a certain amount of seconds, depending on if it's been damaged, but it hasn't been fully exploded yet, it will catch on fire. And then this timer node we start when it catches on fire when it's a little bit damaged. So that way it's, if you don't keep damaging it, it will still explode. And what we do is we connect its timeout signal. This and then and this is where it's fucking convoluted and I don't like this, is we create a new object called a callable. And whenever you see the word this, you'll see this a lot. This means
I'll see this a lot. Okay.
Yeah. This means this specific instance of an object. So if I wanted to say, if I wanted like a node to reference its own HP, I would say this dot HP or this dot smoke or this dot barrel max HP. You don't always necessarily need to say it, but sometimes there is ambiguity. For example, in this in this instance, you need to say, okay, because the callable function is, it creates a new little, essentially it does its own event handling. It's stupid. I don't like it. But basically you're saying, okay, the first parameter of this is what object contains the function we want to run when timeout happens. And we say, well, we want to reference this. So we want to reference this instance of the barrel. And then name of just means get the name of the function as a string, because this thing is stupid. Godot's really stupid in this regard. They use strings to know the name of functions. And now if I renamed the die function, I would have to change, similar to this, I would have to find any instance where I did that. Name of just returns the string. So then if I refactor it later to change the die function to delete or something, it would update it here automatically. I don't have to worry about it. So anytime a node, and every node has a list of signals that it can call out. And that just shows in the editor, and I'll show that as well. And then you have to manually connect these things. And generally speaking, it's 1-to-1. So this one timer, you'll generally only connect it to one function instead of the other method of where you're kind of like many things can subscribe and it just emits into the void, and then other things can choose to act upon it. This is basically just, okay, when this happens, call this function. It's a little limiting, but you got to deal with it. So then the other thing here is, and this is even more kind of esoteric, but this is basically, what would you call this? So structs. You'll use structs in things, even if you're not thinking you're using them, because structs are just, there's certain types that are a struct by default. So a vector 3 is basically just an XYZ coordinate, right? So like the position of a node, like where like an object, an actual like physical object in the game, where it's located in the world is stored as a vector 3. And this is what's annoying, is that you can't modify parts of a struct directly, just in C#, because that's just how C# works. But that's a pain in Godot, because a lot of the times, say if I have like a node that is physics based, and I want to like say add to its y velocity, so it's like vertical velocity, in GD script, which is the other language that Godot supports natively,
Stands for goddamn.
yeah.
Sorry.
I do not like GD script personally. Among many reasons, I'm not gonna whine about it right now, but C# is just nicer.
Okay.
But in GD script, a nice thing that you can do is I can say like, oh, take the position, just the X part of it, and I want to, set it to 100, like teleport its X coordinate to 100. You can't do that directly in C#. Instead, what you have to do is you have to make a new copy, like a temp copy. I'll hide myself here for a second again. Oh shit. You have to make a temp copy, set the position on that temp copy, and then set your original one you wanted to modify equal to that temp copy. And now that becomes a problem. And I've personally experienced the problem with this, is there is some bugs that can happen where, because you're copying, you have what's called a race condition. So when multiple things are modifying the same thing at the same time, what happens if something modifies it in between when you last checked it or not? Right?
Oh, then it's wrong.
Yeah. So you'll see this in a lot of things. Usually it only happens in things like C, because you have what's called time of check, time of use, which means I checked a thing, and then I did some stuff, and then I go back and I use that thing out of the same variable. Well, what happens in between that time when you checked a thing and then you read that variable back in is it could have been modified. Now you don't know what you're operating on. So I could have said, so an example from like a security perspective of this would be like if I said, hey, here's my password and my username, and then it goes, okay, I'm gonna go run a function to check and make sure it's valid before I run your command, and then it goes off and checks it, and then meanwhile I change my username to be or like say it goes to check to make sure that my password is valid, and then in between when it checks the username and password, I change my username to like admin. And then it comes back and goes, yep, your password was valid. I'm going to take your username and password again and then go do stuff using that and give you the authorization based off of your username. Well, now I'm logged in as admin, and now I can do whatever the fuck I want, you know? Security vulnerability.
Oh, yeah.
Um, in games, it really doesn't matter. You just end up seeing more things like unpredictable behavior because you don't know what part of your code where is like being given priority on modifying that variable. But
Sounds like a feature.
yeah. So I personally had an issue with this where I was trying to re-implement the Half-Life 1 movement system in C Sharp. Now there's a GD script version of it, but it makes heavy use of this functionality here of being able to just say like add velocity to just the X coordinate or just the Y coordinate or just the Z coordinate. But instead, every time I wanted to add velocity, I had to do this. And because of that, because it's creating a new copy, other parts of the code that are modifying other parts of the variable, so the X, the Y, and the Z, they go to modify it, but then it gets overwritten because I copied the old version of that velocity and then shoved it back in there. And now this other code that exists out here that tried to set the Z velocity, it just gets nullified because in between when it got modified, I copied it out, did some changes, sent it back, and then this code's like, what? And so and because of that, I had issues where like I couldn't ever jump or I couldn't ever move in a certain direction because of that. So that's an
So was
annoying thing.
the fix for that just doing it all in GD script or?
Well, pretty much. The way that I had solved that was I just said fuck it and stopped trying to rewrite it. Eventually, I'm going to have to rewrite it just because I need everything to be in C Sharp. But for now, I don't worry about it. But the real solution is program your thing in a way where you are not having race conditions, where multiple things are modifying the velocity all at once or modifying the same variable all at once. They need to all go through one kind of funnel point where everything says like, hey, I want to add this velocity to this, and then this velocity to this, and then a single function computes it all. So that's just a consideration, I guess. So, and then one last thing here, and we'll get into like actually looking at the Godot editor. So everything that's in Godot is organized into what's called a scene. And now every map in Godot is called a scene, and they're organized in a tree structure. So think of it like folders in your computer, where like this contains these things, and then these things are under this, and then they're under this, but then these things are like next to each other. And scenes can be entire maps. So like in this thing that's minimized right here is all of the actual like level geometry. So all of the like map level parts. But it can also be individual parts of maps. So like this section right here is all just like pickups that are in the world. And these are all, and that's what this little clacker board is here, this is a individual scene that is referenced into the current scene. And what's cool about this is that they, which is what this part is when you instance a new scene, it makes a copy of it, essentially. And if I go, so like this is all, like these ones are all here are like the gun pickup, and then these ones are the health pickups. If I go and change the model for the health pickup in the original scene, it changes it everywhere that you are importing the scene. So all of these would change to the new model, and I don't have to like redo anything.
Okay, so you definitely want to just like
Yeah. You want to,
structure it like that as opposed to make it a new scene.
yes,
You want to import the scene rather than make it a new one then when it comes
yes.
to items like that. Okay.
Yes. Yeah, you want to be reusing as much stuff as possible like that. Because then it will update every instance where it's like referenced, but then it's also like you have the same consistent behavior all the time because all of, it's literally the same exact thing copied. It won't be like, oh, I put down an item, pick up here, but it's the wrong like collision size or something like that because I didn't, use the same exact one every single time.
Right.
Um, and so some other terminology, every object in a scene, every one of these things is called a node. And every node has a parent. So like this pickup here, its parent is this node that I use just for like organizing that's called pickups. And then this node's parent is the scene root. And the scene root's the only thing that doesn't have a parent because it's the root.
It is the parent.
Yes. And then nodes can also have multiple child nodes and sibling nodes. So like the light map right here and the world environment and the navigation region and the pickups, these are all siblings of each other, meaning they're on the same like hierarchy level. And then as an additional thing, for anything that needs to like render over top each other, so like GUI stuff, this is kind of unintuitive, but things at the bottom will render on top of things at the top.
Wait, what?
So think of it as like in your mind, kind of like,
It's like reverse layering.
yeah, in your mind, kind of think of it as like the stuff that's last is things that are kind of layered on the cake at the end, meaning they'll be on top, is the way I kind of think about it. So like,
That's so backwards to everything I'm used to.
yeah, it definitely trips me up pretty frequently where I'll be like, why the fuck is this rendering over top? And then I have to like go look at the like live editor and see like, oh, right, this sibling is above the other sibling. So theoretically, if I put like the player down here somewhere, or say if I put the player like scene up here, and then down here I put like some GUI for like when you're looking at an object in the scene, it makes a little thing pop up on your screen. If I press escape and like go to the pause menu, because the pause menu is part of the player, this thing down here will render on top of the pause menu. So that's just something to like keep in mind a bit. And then all of this stuff can also be done via code. So like for the like explosive barrel example, we have we can take that explosion scene. So the actual like particle effects and the thing that does damage is in its own scene. We can instantiate that, which is the verb form of instance. We can instantiate that, make a copy of it, and then we'd say like we're putting in this just temp variable called I, and we set its like global position to where it's equal to this global position, which is the explosive barrel. So here's an example of the kind of ambiguity between like, wait, whose global position? We're saying the I, the instance, versus the barrel. And then so the barrel dot get tree, this is a function you can call on any node. You can say get tree, which gets you the whole scene, and then dot root will reference the root node, so whatever the root in the scene is. So if we said like explosive doors down here, we'd say what this is doing is we say this dot get tree, which gets us this, and then we say root, which references that. So that's how we can like kind of traverse the tree without knowing what exactly is in the scene. And then we say add child, which there's add child and there's also add sibling. So if I was in here and say I wanted this health pickup to add a sibling of another health pickup, so every time you pick up a health pickup it spawns another one, I would say health pickup.add sibling, and so it sets its parent to be this right here. But then what we're doing
Okay.
is we're just saying, okay, get the root and add the child to the root, because we don't want, in this case, we don't want the explosion to have anything as its root besides, or like anything as its parent besides the root, because the barrel, the next line is we destroy it. So if we said barrel.addChild, you would literally get like one frame of the explosion happening before. Actually, I don't even think you'd get that. You wouldn't even
Or
see the
die.
explosion, because when something dies, it kills all of its children too. So,
Okay.
which sounds very gruesome out of context. Um, but basically, if I said pickups dot die, it would kill all of these pickups, because anytime a node dies, it takes out all its children with them. Useful for when you need to clean up stuff, but also not useful when you need to be able to keep something there, but also like spawn something next to it. And then, theoretically, this also could just be add sibling. It doesn't necessarily need to be add child, but it makes it easy when something is added to the root, because then you can like really see it in your scene tree, because there's a live editor you can use, and this live editor lets you see like uh what nodes are currently in the scene. So any questions on that?
Not yet.
Okay. All right. And that is basically the presentation. So now
Oof, we survived the lecture, boys.
I'm going to kind of show some of this in real time. So
Oh boy.
this is actually like the Godot editor here. It looks a little different from what it does on default, because I have a specific color scheme, because I really like the old green hammer editor look. So I have it as a color scheme like that. As well as on the side here, I've moved all the sidebars, because you can just reorganize them like this. I've moved all the sidebars onto just the right side, because I'm weird and I like having it all there, so I have more of a wide view of the scene. Let's see. So we've got, so this is the whole like scene tree here. Some of the things that are important to note is we have a couple different widgets here. The visibility, so the little eyeball here, means does it show up in the scene? And this is all of the stuff you can set in your code. So if I wanted something in the scene but I didn't want it to be visible, I would just say node.visible. And so you see this decal. So I've got two decals here. I've got a little like a bullet hole decal right there. And then I've also got the like game logo like decal. And so I can set each one is individually visible, or I can take their parent and I can set all of them as invisible or visible like that.
Got it.
So then there's locking a node, which basically just means I can't, like, if I select this, I can't like move it or anything. It won't let me move it. If I unlocked it, that
Whoa.
things get a little wacky, and you don't really want that. So I usually leave like my anchor nodes, like something like pickups, that's locked, because otherwise then all of the pickups would move like that, and I don't really want that.
Right.
So if you see something that has a this little scroll on it, that means it has code attached to it. So like the explosive barrels here, these have code attached to them, and so I can actually go here, click on that script, and then it will open it up in Visual Studio here. And you can see, this is all the code for the explosive barrel. So like this was the like dying function that we looked at a second ago. This was its ready function that we looked at. Some other miscellaneous things that are cool. Godot does this thing called exports. So on our little variables here, if we say export before it, That means if we're in Godot and we click on something that has exports, that means that we can set these things. It adds it to the little like editor here.
Oh, that's cool.
And so, and you can even see this. So destructible object. So this is where we get really cool with like inheritance. Explosive barrel inherits from destructible object. And so you can say, okay, well, what's a destructible object? A destructible object has a mesh, so a model. It has a collision shape, so it's like hitbox. It has a packed scene, which basically just means another scene. And we have one for gibs. So when something explodes, we can have gibs fly out. And then it also has its HP, so how much health it has. And so we can see the difference here with our explosive barrel. We export also its smoke particles, the scene that it should load when it's exploding, the timer node that it should have, and then the barrel, like HP. And so we can see like, okay, we set the barrel max HP as 4 here, even though we have 2 here. Theoretically, that probably doesn't need to be there twice. But you can see how like, okay, yeah, there's the mesh, the shape, the gibs. And then up here, there's the smoke, the explosion scene, and then the timer. And both of those things exist there. And so the if we go back to destructible object, we can see, okay, well, a destructible object is a rigid body, which a rigid body just means that it's like a physics object, right? But we also inherit iHeartable. So iHeartable is an interface, and this is the like naming prefix that you usually give stuff, is if it's an interface, you put I whatever in front of it.
Oh, okay. I for interface.
Yeah.
You're,
Um,
I I thought it was just like, oh yeah, you put it if object is hurtable. I hurtable. That makes sense.
yeah. Because like
No,
for an
I for
example,
interface.
an interface that's used a lot in C sharp that exists as like a C sharp thing that's used just in the language is I enumerable, which means anything that inherits I enumerable means it's something that you can iterate over. Like it's like a list of some sort of objects. So like a table, an array, a list, whatever. All of those
Okay.
inherit I enumerable. And so then I can say, okay, well, what's iHeartable? And I can tab over here. And all iHeartable is it says, oh, it defines something that can take damage and something that can die. So that is very useful because now we have a way to define anything that can take damage without needing to know what the hell it is. So in our script that runs the explosion itself, what we can say is, okay, anything that overlaps its like collision sphere, so like it's like AoE damage, we just say grab all the nodes that are overlapping its sphere, and if that node is an iHeartable, tell it to take 2 damage. And then that node then receives the signal to, hey, I'm going to take 2 damage. And then it can decide to do whatever it wants with that. Either it can just take the 2 damage raw, or it can say, oh, I have, if I'm the player, I have like a armor level. So then we can say, okay, take whatever that number we're getting in there, divide by the armor level, and then we actually do that damage to ourselves. And so that way, I'll show an example here. The player is still bugged, so the player can't really take damage right now. But for other things like destructible objects.
Oh, they're falling.
Oh, we didn't. Oh, what the heck?
Whoa.
Oh, something's bugged. We can't pick up items.
You're welcome.
What the fuck? Why can't we pick up items? Dev, you broke something? Okay, well.
I happen to know one of the devs, so I'll let them know for you.
Yeah, go file an issue with them.
Yeah, I got you.
But okay, so for example, this barrel and this that's actually really fucking weird. Now I'm gonna be focusing on that. Why can't this why is it not adding anything? Well, this is why we have our debug here. So we have our local scene. So this is like what we set up and all the things that we dragged in here. But remote shows what nodes are in the scene right now. So in here I can say search for player. And so we know player is under prefabs. It's under or no, it's under maybe player start. Yes. Under the door scene, and then we have their player start. And so we can say like, okay, well what's wrong with the like player right now?
Oh yeah, there you go. Blame the player.
Not sure. That is odd. Let's see. So the player, and then we go to its controller add-ons. That is very strange. I'm not sure why that's not working. Well, now I have another thing to fix. But theoretically, if it's working, this barrel here, which actually I can probably do this. If I figure out, or if I go to like this barrel here, where's that barrel in here? That barrel is, okay. We're gonna manually do this here.
Okay.
So if we go over to this barrel, and then we say, we pause it for a second, and then we say, that, which barrel is it? Number 5?
5.
Okay. So if we say, take this barrel, that's barrel number 5, and then we set its HP to be 0. Oh, that didn't work. Shit. Fuck.
I was like you said, it's max HP to 0, but it's HP still 2.
Oh,
That'd be my guess.
damn. No. Okay. That didn't work. Anyway.
Womp womp.
Theoretically, barrels and crates, they both inherit I hurtable. So when this explodes and the explosion scene happens, it checks all of these other things and it goes, okay, deal, 2 damage to all these other things. And then the barrels, they only have 2 HP. So then what happens is the barrels then make all the other barrels catch on fire and explode. And then those explosions then also do damage to the crates. So then the crates explode. And so that's when you start having like, kind of all of these like emergent gameplay things of like, yeah, because all of these things understand each other of they all have, they all inherit some common interface or they all inherit some class, then we know in our code, okay, just find everything in here. Because the other way that you would have to do this is you'd have to say, okay, well, if something is a barrel, or if something is a crate, or if something is a player, or if it's an entity, or if it's a different entity, or whatever, you'd have to have, 100 different lines here for every single thing that could possibly take damage. And that's really dumb to do that. You shouldn't do that. You inherit an interface.
You can just make it all an else if. What do you mean?
Yeah. You can make your 10,000 line else if statement that your whole game is wrapped in.
Sounds great to me. More code equals better programmer, right?
Yep. Fucking lock maxing. But yeah, so if you inherit an interface or you inherit a class, then it doesn't need to know what the fuck that object is in the scene. It just needs to know, yeah, it's hurtable, so run its hurt function. And that is useful for other things like interactables. They just have a simple function called interact. But that is super useful because then my player add-on here, I can just say, okay, if what we're looking at, ignore all this. This is code that's going to disappear here very soon. We just say, yeah, if the thing that we're hovering over is interactable, and if we just press the interact button, so E, then run its interact function. So if we're over here at these doors, when we're hovering over the door, our current interactable is what we're looking at, and then we hit E, and then the door opens, and then the door closes.
Yippee.
Or theoretically, if things work right, these items on the ground are interactable. So when we hit E on them, theoretically, they should be added to our inventory. And then there you go. We have, we have the, I think I know why that's broken. I was just thinking about it now. Technically I'm in the middle of refactoring a bunch of stuff, so there's a lot of things that are going to be broken. The item's not working. I just realized is because I'm reworking how interactables work. But because because they inherit interactable, theoretically they should get added to my inventory. And doors and inventory items. Oh yeah, this one's the like sliding door. But see, like, yeah, I mean, there's another use case is like regular doors and sliding doors both have different code that governs how they work. So like sliding doors don't close on you. They won't like clip you through the ground. They wait for you to leave. So it is,
boo.
When I sit here, it won't do anything until I walk away.
Wait, what does that great text in the sky say?
This has got milk.
What?
That was added by one of the other devs as a funny Easter egg in the dev world.
That's great.
But because of that, you can define your own functionality. Like these doors, they don't, you can close it on yourself and kind of clip through the wall. But that's a very very small
speedrun strat.
Like, yeah. That's a very small thing that I can fix elsewhere, but like, like you can define different functionality, like doors that are slightly similar. They both inherit door, right? I think, or they both inherit, or they might both just inherit. See, do I have iDoor in here? Let's see, where's my interfaces? Oh, yeah, I just have iDoor. So doors have an interact, an open, and a close. And so, yeah, so you can see there's the standard door and then the sliding door. So like our sliding door, we have like, this is our function here that says like, oh, are we not colliding with the player? Then we can close. Versus the standard door is, because if we look at this, the doors have two collision boxes here. One checks if you're in the positive direction from the door, and one checks if you're in the negative. And the reason you do that is because it's like, well, if I'm on this side of the door, when I go to open the door, I want it to open away from me. But if I close this door and then I open it this way, I also want it to open away from me.
So then you never have to worry about the player getting embarrassed by pushing a pull door.
Yeah.
That's very considerate.
But yeah, because like, I mean, that's useful for just like, that avoids half the cases where like, oh, you go to open the door and then it like swings out and smacks you into the wall and then you collide and clip through things. And you don't have to worry about like, programming it in a way that like, because basically it's just two different animations that it plays through of like, oh, you're on this side, open in that direction. Oh, you're on this side, play the other animation, and then it just plays it in reverse to close it. But yeah, like interfaces are really cool. I really like interfaces. I only relatively recently, like in the past like year, learned about how to actually use interfaces, and I wish I would have learned that sooner. But they're super, super, super useful. Let's see, what other things do I want to show? Okay, so like here's another kind of example of interfaces. Is for all of the like movement schedules here. So like the AI, where the fuck are you? Are you in here? Bro is stuck.
It's just a dude.
So like, I mean, here's another example. Is in like 3 lines of code, pretty much, I just added, oh yeah, NPCs, they also inherit I interactable and I hurtable. So you can interact with and you can hurt them. And then what I do is I say, oh, when we're interacted with, toggle between a following schedule or a wandering schedule. So he's wandering right now. But if I go up to him and I click E on him, now he's set to a follow schedule. So now every time he like does his little cycle through, he'll grab my position and like try to follow me. And so I can like lead him, you know, all the way over here if I want. Here he comes.
Look at him go. He's just a little guy.
And then if I hit E on him again, then he'll go back to like patrolling around randomly wherever he wants to go. And so that was like, because of that, I just just toggle between these different schedules. And these schedules are defined out here. And so this is like another kind of like esoteric thing you can do. In a individual file, like the actual like, C# code file, you can have multiple classes in here defined. You can technically have your all of your program in one file if you're insane. Because from the perspective of the code when it's compiled, it's basically all lumped into one thing. But that makes it like fucking impossible to like find where your stuff is.
Right. As opposed to just having separate files.
Yeah. But like, so out in the same NPC, because pretty much the only place that my convention that I use is if I need to define another class that's literally only ever used by a certain class. So like an NPC like base template is only ever going to be, is the only one that's ever going to be using NPC schedules. So I just define the classes for the NPC schedules in here. And that's just kind of outside of the, because like this is the bracket that closes the, the class defining the NPC here. And so this is just kind of stuck at the bottom where I'm defining an interface for like, okay, get the navigation points. So like what 3D points in the world should we move to? What the next schedule should be. So like, say if we have like a chase player, we'd probably want to do like chase the player and then run another schedule right after that says look for the player, because they might chase the player around a corner, but then the player might have been gone. So we need to like search for them again to like figure out, if we're searching, and then if we find somebody, then we go back to chasing. But if we don't find them, we need to start going into, investigation and start like looking around the area to see if we can find them. And then, eventually investigation can lead back to, idle or wander. And so we define all these different things. And then what I do is I create a class that defines the specific like functionality. So like, the searching schedule, what it will do is it gets a random radius, 3 random points from the player. So if we're trying to search for where the player is, we get a we get a random point in like a radius of 10, 5, and then 1. So it's like we're narrowing in on a player's position. And then we say, well, if we're searching and then we don't find them, then we just go back to wandering. And then wandering returns another wandering. So we basically will always loop wandering. Versus something like schedule follow player is we will always loop following the player. So that's kind of our like what's kind of called like a state machine. This is how I'm kind of constructing my state machine, is it's like individual little schedules that get loaded in. And then what we do is we say, let's see, every time we reference this, we say, okay. Right? Yeah. So basically we say like, okay, update our target location every time we set, okay, here we go. So when we set the current schedule, this is an example of getters and setters from earlier. Also, this is like totally just off the cuff scatterbrain craziness. So if you have questions, again, let me know.
Yeah, we'll see.
So like right here, we have a bool, right? Or like this one's a better example. So this is just a true or false of, is navigation enabled? By default, we enable navigation because by default, most of the time we want NPCs to navigate. But we can also set a variable with a getter and setter. And get will is basically if I in my code elsewhere say, what is the value of current schedule? We can return it there. But we can also say, okay, we can set custom things of when we set the schedule, what do we do? Well, what we do is we say, take this like little like kind of internal temp reference and set it to be whatever we're setting that there. But then we're also going to say, okay, while we're doing that, clear all our navigation points. So we store a list of points that we want to navigate to. We're going to clear those. And then we're going to say, get the navigation points from this new schedule. And then we're going to say, update our target, so where we're heading next, to be equal to the first item in that list. And then we also print, yeah, we set a new schedule. And so that's what you see in here when we say, this NPC is now wandering, or he's now following. Is because this code in here was just run that goes and sets up the navigation system there. And then that's all using interfaces. So then we don't have to worry about like, oh, is it an idle schedule, or is it a, this or that schedule? We just say, yeah, it's a schedule. And then we know what functions should be in it. And then we can have all sorts of custom functionality inside of the schedule for each one of these functions. Technically, this could also be a class. There's no reason it has to be an interface. Again, I like interfaces now a lot just because you can slap them on anything and it can inherit multiple things. Like, for example, if I wanted to say add scripted sequence where it can inherit a schedule, but it can also inherit like some other custom behavior elsewhere, we would just say, comma, whatever other interface, like scripted event thing. Let's see, what other interesting C# things are there? I guess this is like something that's like semi unrelated to necessarily C#, but it's a cool thing that Godot has, is a level importer script where basically, because like this scene right here, let me actually go open this up. There. Blender and models and this model. So,
Whoa.
so all of the like doors and explosives and the player and the little NPC and the crates and the doors and the this and the that, these are all just defined in here. And I just make sure that the name contains like dash sliding door or dash standard door or dash crate or dash explosive barrel. And then my code goes through, finds those things, and actually sets up the scene by attaching all the logic and scripts to it. So if I click on this and then I go like editable, it goes and it actually finds all of the crates here, and it extracts out the like models, and then it creates a new example model based off of the template, and then it fills in all the information from that, like all the mesh, the actual like model and everything. It attaches all the code, and then you have all of these objects in here that I didn't have to manually attach the code for all of this. It's just done automatically via setting it up in here and then setting up my importer script that just goes and says, hey, yeah, if this contains sliding door, make a local copy of the sliding door, set up all of the like the mesh and everything, and then call it good.
Is that what puts it on the map, or does it just include it in the scene but not like on the
Yeah, so it actually like so like what I can do is I can say like the door test scene. If I just drag this blend file, I don't even have to export anything from Blender. I'm literally just making the blend file and then saving it in the folder. And then I literally can just drag and drop it. And then it goes and you see it automatically attached all the code and all the scripts and everything to where it added the little dude there.
Oh, okay.
Attached all the scripts, all the models, the 3D collision and everything. And then that's just there. And then you don't have to like place all that stuff manually, which is super, super cool.
That's freaking awesome.
The like end goal with that for me is to make it where like pretty much all the level design happens in Blender. Like if you want to put a player there or like an item pickup or an enemy, you just place it all in the blend file and just like drag and drop it in there with like the asset viewer. And then Godot handles the rest. And then you just drag and drop and then you're done. And you don't have to do really that much at all in terms of like fucking around with placing individual items or anything. Because it's like, well, what if you change, the location of where a room is in the blend file? Well, then I'd have to go, I have to go find that in there, and then I have to go find all the item pickups that would have been in that room that are now clipping in the wall, and I need to like adjust them. And it's like, no, just put them in.
It's all just done in the blend file already, then you just bada bing, it's already there.
But yeah, that's pretty much what I wanted to go through for as like the kind of crash course. Here's a bunch of information. You don't need to know it all by heart right away, but to kind of point you at things and be like, look, these are all things that exist. And then when you actually later understand how these things work, you'll be able to like remember, oh yeah, that's a thing.
Like, oh yeah, he was talking about this, and this is okay. So
that's all I had. I don't know if you have any questions or if you want me to explain anything more or if your head's full.
A head full. Thoughts congestion.
Okay.
I'm sure I'll have a lot more questions once I'm actually doing it.
Yep.
And a lot of repetitive questions when that time comes, but but for now, a head full.
Okay. Okay, so we can probably call it there then. Next week,
It was a good lecture.
I'll probably need to, before stream, make sure everything is all set up properly for you, because we are actually going to be screwing around in Godot and making stuff finally.
Okay, so I'll want to make sure that I have Godot installed and ready to go.
Yep, Godot. Obviously, you have Blender, VS Code, and then
Okay.
I might need to have you install .NET development, but we'll see.
Okay. Sounds good.
All right.
Thank you very much for the lecture today, sir.
Yep. Very exciting, I know.
Professor Skeleton. We'll probably I had something I was gonna add on, and then I completely lost it the second I started talking. So if I remember, I'll shoot you a message.
Okay.
But yeah, thank you again for taking the time to do this for me.
Yep.
I appreciate it.
All right. I will let you go.
Ooh. Dimps cough. Oh yeah. All right, peace, dude.
All right. See ya. Okay. And that is lecture for today. I am probably, let's see, probably just gonna call it for here. Not gonna bother rating into anybody because I don't know if anyone is streaming. Maybe. Let's see. Is there anyone streaming? Oh yeah, we've got someone streaming. Let's go raid into okay, well that doesn't even want to fucking load for some reason. Okay. Or wait, I clicked the wrong button. Shit. All right, let's go right over here. They're working on a very cool Doom mod thing. Let's see. Oh yeah, I keep forgetting it's Monday. And I guess I should know that it's Monday because it's game dev day or game dev bootcamp day. But I don't know what fucking day it is. Yeah, Tuesday I'm off. And then Wednesday we'll probably pick up more with decay chain programming. So we'll actually, I'm probably gonna at some point fix the stuff that I broke last stream and like started refactoring and then never got around to refactoring. We're gonna do that again. I'm probably gonna work on that tomorrow a bit actually. And then I'll get around to I'll have something working on Wednesday. We'll say that. I'll think of like what I want to actually do that's like interesting to look at on stream. But yeah. Okay, I'm gonna raid. Adios. Bye bye.